Next, we're going to talk about variables. See, the way this works is we ask questions on a survey, and questions are really giving us information about variables. So here's our example. Our survey question: what is your college major? Now, I would do a close-ended question. I would give a list of all of the possible college majors at Copper Mountain College and tell them that they can check their majors. So if they're double majors, they can check 2, otherwise they just check 1. And that survey question is giving us a variable. College major is a variable. It varies. I'm a sociology major. Person over here is a psychology major. Somebody over there is an economics major. Look, 3 different possibilities. The thing varies. It's a variable. Here's our definition of a variable. A variable is a property of people or objects that takes on 2 or more values. So, for example, we could say there's a table. Does the table have legs? Does it have 4 legs, 3 legs? Maybe it's weird and it's screwed into the wall and it only has 2 legs. The color of the table, that's a variable. A table could be brown, it can be black, it can be red. The table can have a variable like height. The height of the table, that can vary. I have one table that I use for a stand-up desk. I have another table for sitting down. So you've got variable heights. So there's a lot of variables that we can use to talk about a table. An important quality of variables for research is that they have to be exhaustive. So, for example, in my previous example with college major, notice I said for my choices, I'm going to give them a close-ended question, and I'm going to have a list of all of the majors at Copper Mountain College that are possible. And they have to choose from that list because they're a Copper Mountain College student, and those are the only majors available to them. It's exhaustive. All the possible options are there. There's no other options. So whenever we write a survey question that we're trying to look at a variable, the choices have to be exhaustive. Somebody shouldn't say, wait a second, there's no choice for me. If they say that, then it's not an exhaustive variable, so you want it to be exhaustive. Mutually exclusive means that if you're in one category, you shouldn't be in another category. For example, what if somebody said, I'm a veteran, I have served in the military, and I actually got reactivated, and now I'm an active duty service member. Then they would have to choose 2 categories, veteran and active service. So usually we say, hey, just choose one category, and we try to set the question up where there really is only one, there's one choice for everyone. If you set up your whole survey, and the entire survey people are going, well, I could choose this and I can choose this, and on the next question I can choose this and this, then your variables are not mutually exclusive. Sometimes that's okay if it's not mutually exclusive. Like, let me give you an example. If I said, what streaming service do you have? You might say, oh, I've got Netflix, I've got Hulu, I've got Disney+. You've got 3 of them, right? But notice you either have Netflix or you don't. You have Hulu Plus or you don't. You have Disney Plus or you don't. So in a sense, you're kind of setting it up mutually exclusive. It's either you have something or you don't. So same thing with a college major. You have no for 99% of the college majors, maybe 1 or 2 you say, yes, I am a sociology major and I'm a psychology major. I'm double majoring in both, so I'm going to choose 2 boxes. College major for people who are double majoring is kind of the exception to the rule. Streaming services, same thing. That's a select all that apply question. Most questions we're asking in social research are, we give exhaustive choices, and the choices are mutually exclusive. If you have one, it means you're not going to be in another box. So let's play a little game here. Is it a variable or is it not a variable? So if I said to you, male, is male a variable? The answer is no. Male is not a variable, it's a choice. It's not a choice, it's an option. You can be male, you can be female, you could be something else. Race, is race a variable? Yes, race is a variable. It varies. Some people identify as white, some people identify as black, some people identify as Asian. There's different options. You choose one. Hopefully it's mutually exclusive. I consider myself biracial because of my mom and my dad, so I usually take the other category. But notice it is mutually exclusive and usually it's exhaustive. High school graduate, is that a variable? A lot of my students will say yes. They're like, well, you either are a high school graduate or you're not a high school graduate. But it's not really a variable. It really turns everything into a yes or no question, and that's not what we're looking for. We're looking for something that really varies. So high school graduate is not a variable. Socioeconomic status. Sometimes this is like, poor, working class, middle class, upper class. This is a variable. It varies. Some people identify as upper class. Some people identify as upper middle class. Some people identify as working class. So socioeconomic status is a variable. Occupation, is that a variable? Well, ask yourself, does it vary? It does. Some people are teachers. Some people are policemen. Some people are doctors. You state your occupation, so it does vary. Self-esteem. Is self-esteem a variable? Yes, it is. There's many options. You could have high self-esteem, low self-esteem, middle self-esteem. There's self-esteem scales, there's inventories and things, but it does vary from person to person. And their last example is hours watching television a day. Is that a variable? Yes, it is. Some people watch 0 hours a day. Some people watch 7 hours a day. It varies from person to person. So the only two here that really weren't variables is male and high school graduate. I would consider it a pretty poor survey if you just said, are you male? We don't usually do that on a survey. We say, what is your gender? What is your sex? We give the people options and they choose one. That's a variable. Another key term that we have to think about when we're doing social research is constants. So variables vary from person to person and object to object. I gave you the example of my table. I gave you the example of college major. There's lots of variables out there. But constants are something that remain constant from person to person or object to object. The best way to explain the difference between variables and constants is to give you an example. So that's what I'm going to do next. A study is conducted to determine if there are gender differences in fine motor skills among 5-year-olds from middle-class families. So let's identify all the variables in this study. So we've got gender differences, that's a variable, in fine motor skills. That's something that varies. You can have great motor skills or not great motor skills. One of my children had amazing fine motor skills at age like 3. The other one, not so much. Among 5-year-olds, whoa, 5-year-olds is not varying. It's just 5-year-olds from middle-class families. That's not varying either. So we've got 2 variables and 2 constants. We're looking at gender differences, we're looking at fine motor skills, and our constants are 5-year-olds and middle-class families. So please note, whether a trait is a constant or a variable is determined by the nature of the particular study. Usually researchers do this by design. So notice that the researcher here said, I only want to look at 5-year-olds and I only want to look at people from middle-class families. Why? Well, should we be comparing 5-year-olds to 25-year-olds? No, of course. The 25-year-old is going to have better fine motor skills. They've got 20 years of experience using fine motor skills. Well, what about middle-class families? Well, maybe that's most of America. You don't want to look at really, really poor families because there might be some factors there that impact motor skills and gender differences that are unique to that side of the socioeconomic spectrum. And the same thing, we don't want to look at super rich kids because there might be some differences in fine motor skills and gender at the top of the socioeconomic status. So we're controlling this experiment by only looking at 5-year-olds and only middle-class families. The other things are allowed to vary, and we see what we get. This is a very good research design. You have variables, you have constants. It's a pretty good thing to do. So we design studies to have both variables and constants, and I want you to think about why we might do that. I kind of alluded to it just now, but think about why. Another way that we can think about variables is in terms of cause and effect. So this is another one you might want to make flashcards for. The dependent variable is the thing to be explained, the effect. The independent variable is the variable we expect to account for the dependent variable. So I like drawing a picture, it makes it better for me. The independent variable is the cause, the dependent variable is the effect. Notice the cause is making the effect happen, and we call that the dependent variable and the independent variable. This is just language we use in research, and you should be familiar with it, because when I use it, then you'll know what I'm saying. So in class, I might say, hey, is that your independent variable or your dependent variable? And you should be able to know the meaning of that word. Here are our rules for causality. It's not easy to figure out whether X causes Y, so we have to have 3 criteria that are met. First, the cause has to precede the effect. I know that seems kind of obvious, but people forget sometimes. They'll say, this caused that, and we'll look at them and say, but one came first. One came, you can't say the effect came after the cause, came before the cause. The cause must come first. So we have to look at things over time, and when we look at things temporally, we must see the cause happen first, the effect happen second. Number 2, there must be an empirical relationship. We have to collect data and find a correlation that happens. Every time X happens, Y happens. When we find that correlation, every time businesses, look run down, crime goes up. Just because there's a correlation doesn't mean one caused the other. There's a lot of things that are correlated, but they're not causal. So we require that the cause comes first, then the effect. We require that there's a relationship that we can see. And number 3, the most important one, the relationship cannot be explained by other factors. Usually what we're doing in research is we're saying, hey, I found a correlation between 2 variables. When one happens, the other one happens. The cause comes before the effect. And there's a lot of possible explanations for what's causing it. And we're going to try to eliminate all those other explanations. And then we're left with the only option left, which is what I think caused it. And we're going to end class with levels of measurement. This is extremely important. This will follow us throughout the semester. So if you don't understand this is something we're going to practice. We're going to do a lab on it. So this is called levels of measurement. And it's important because depending on the type of data you have, it shapes what type of statistics you need to do. So this is very, very important, and we will come back to this many times throughout the semester. So here I'm going to explain the 3 levels of measurement. They're called nominal, ordinal, and interval ratio. I know these are big words, but you're going to hear them over and over, and hopefully you will become a lot more comfortable with these words. I'm going to explain what each one means. Nominal level of measurement. Okay, this is when we look at the social world and we assign numbers to things, but the number is only for the purpose of naming, labeling, or classifying an observation. For example, I might create a survey and say, hey, what's your political party? Are you Democrat, Independent, Republican, Green Party? And I might give them numbers. I might say Democrat 1, Republican 2, Green Party 3, Libertarian 4. Right? Notice I'm using numbers to look at my data, but couldn't I reorganize it? Couldn't I say, okay, what's your political party? Libertarian 1, Green Party 2, Republican 3, Democrat 4. Yes, I could do that. There's no order to the system. We're using numbers, but there's no order. Same thing with religion. If I say to somebody, hey, what's your religion? Are you Catholic? Are you Jewish? Are you Protestant? And in the computer, I'm going to make Catholic 1, Jewish 2, Muslim 3, Protestant 4. I could just as easily make Protestant 1, Muslim 2, Jewish 3, and Catholic 4. There is no order to the data. I'm using numbers to represent Catholic, Jewish, Muslim, Protestant because computers love numbers and it makes our life easier. But the number is really there as a naming, labeling type of thing. Okay? So it's called nominal level of measurement, and it's when there's really no order to your data. It can be totally changed in order. Race is another example. African American, Latino, Native American, you can rearrange those. There is no order to race, and you just give it, any order works. The next one actually does matter. This level of measurement is called ordinal, and it's a ranking from high to low. So for example, social class. Social class is an ordering. It goes from working class to middle class to upper class. And you really shouldn't rearrange that order because you're talking about from less money to more money. So what if we said, upper class, working class, middle class? That wouldn't make sense. There is an order to the data, and when you give numbers to it, when you make working class 1, middle class 2, and upper class 3, there is an order that's being captured that you want to keep. Other examples I can give you. What if we do something like a Likert scale? Strongly agree, neutral, disagree, strongly disagree. That's an ordinal level of measurement too, because the order matters. We're going from the most agreement to the most disagreement. So strongly agree would be 1, agree would be 2, neutral would be 3, disagree would be 4, and strongly disagree would be 5. Could we switch around the numbers and make strongly agree 5 and strongly disagree 1? Absolutely, you could. The idea here is that there is a ranking or order that we're holding in there. But the numbers that we give, it doesn't matter whether we make strongly agree 1 or strongly agree 5. It doesn't matter, as long as the order is held intact. The last one is called interval ratio levels of measurement. This is when variables are measuring with all cases using the same units. So height and weight are interval ratio. Age is interval ratio, income is interval ratio, SAT scores. So if I say to somebody, how old are you? Usually people are going to tell me how old they are in years. They're going to say, I'm 42 years old, I'm 17 years old, I'm 25 years old. If somebody told me their age in months, I would probably roll my eyes and go, get out of here. We all use the same units. Income, same thing. Usually, you're going to be more specific and say how much income do you make a month, or how much income do you make a week, or how much income do you make a year, but we're all going to use dollars. We're not going to try to use some sort of weird currency that no one uses or talk about our gold or anything like that. We're going to say something like, hey, I make $5,000 a month. Okay, I know how much you make. We're using the same units. Now, SAT scores, same thing. It's a standardized score. We're using the same units. So the thing I want to bring up here is that when you're using nominal levels of measurement, there's no units really. It's like, I'm Catholic, I'm Protestant. there's no units there, right? Same thing with something like Likert Scale, strongly agree, strongly disagree. We know that I strongly agree and you only agree, but we don't really know how different we are. With interval ratio, this is the best data possible because we're talking about a unit of measurement where we know what the differences are. If I say I make $5,000 a month and you say you make $6,000 a month, we can subtract those numbers and say, ooh, 6,000 minus 5,000 is 1,000. I make $1,000 more than you do. So it's a very, very good level of measurement, and it's powerful. We want to use interval ratio whenever possible. The best data is interval ratio. So it's a hard slide to understand, but I hope you'll get it. There's a cumulative aspect to this levels of measurement. Variables that can be measured at interval ratio can also be recoded and measured as ordinal or nominal. But variables that are measured at nominal and ordinal cannot be turned into interval ratio. So let me give you an example. Interval ratio, let's say we're going to look at this bottom right corner right here. It's the best type of data we have, and it's going to tell us, one person says they make $6,000 a month, the other person says they make $5,000 a month. So we know how much higher one person is than another. It's $1,000 difference, right? Well, can we tell if one person's making more or less? Yes, the person who's making $6,000 makes more than the person who makes $5,000 a month. So we know whether it's higher or lower. And can we tell whether it's different or equivalent? Yes, it's different. One person makes 6,000, one person makes 5,000. So interval ratio tells us all of this information. We know how much higher, we know whether it's higher or lower, we know whether it's different or equivalent. Nominal, on the other hand, is the worst type of data, because all we know is whether two people are different or equivalent. I say I'm Protestant, you say you're Protestant. We're equivalent. I say I'm Protestant, you say you're Catholic. We're different, right? That's all you get to know with nominal level data. We don't know how much higher, how much lower. We don't know how much the difference is. If somebody says they're different. You know why? Because what's a Protestant minus a Catholic? It doesn't make sense. You can't subtract a Protestant from a Catholic, but you can subtract money, you can subtract height, you can subtract time. If somebody says, how much time do you spend with your children? I could report, I spend 5 hours a day with my sons. Somebody else can say, I spend 3 hours a day with my daughters. 5 minus 3, I spend 2 hours more with my kids than you do. So interval ratio is the best type of data. Nominal's kind of the worst, but we use it all the time. And ordinal is something in between, because it's just as good as the nominal level. We know whether something is different or equivalent, and we know whether it's higher or lower, but we just don't know how much higher or lower. If someone says they are middle class and somebody else says they're working class, it's not actually a really good variable, because maybe the person who's working class is making $58,000 a year, and the person who's middle class is making $65,000 a year, and they're really close to each other, but one person identifies as working class and one person identifies as middle class. So ordinal, it's good, but it's not great. The best is interval ratio. Okay? I know that this is your first time hearing these concepts, and it's going to be hard. We will practice a lot. This is something we're going to come back to over and over, and I think you're going to do great.